to perform the following operations on linked list. So first we'll say insert. In insert beginning, we will insert. At the end, we'll insert. And after a given item, we'll insert. After a given item. Then we'll delete from the linked list. This is one more operation. Then we'll traverse, means visit all the nodes and search for a given node. So these are the operations. Then these are the operations we'll perform. So we'll insert beginning, insert at the end, insert after a given item, delete a given node based on the value, traverse all the data items, search for an item. Now, normally when you want to do this kind of operations on any data structure, generally we write a menu-driven program. So in C, menu-driven programs are done with help of do while. So the menu, what I'll do is I'll display menu, first option, insert at beginning. This is the first option I want to have. Second option, insert at the end. Insert at the end. Then insert out of given item. Insert after given item. So this is the menu I'll display, given item. Then fourth one is delete a given item. Then search, sorry, we'll say traverse. Traverse means visit all the nodes. Then what we do is we'll say search. We'll say search. Then seventh is exit. Then after we display the menu and all menu options, we'll say enter your option. This is how we are going to proceed. Enter your option. Then user enters one of this 1 to 7, and if one of the option is entered, we have to perform the corresponding operation. So this is how we proceed, and we'll be taking one by one. First, we'll try to display the menu, then we'll proceed. So I'll write here a program. So I'm taking a new program. I'll say hash include stdio.h. So I'll not do anything except just displaying the menu. So I'll say int option. Then we'll say do. So always do while we use for menu. So we'll say while option not equals to 7. If it is not 7, we have to continue the program. If it is 7, it is going to be terminated. So here we'll display the menu. So printf. I'll say \t menu. Then all options I'll display. Printf first option 1 is insert beginning. Is first option. So we'll have all 7 options. So this is 2, 3, 4, 5, 6, 7, and we'll say enter here. Insert at the beginning, then 2 is insert at the end. Insert at the end. 3 is insert after given item. Given item. Given item. Fourth is delete. Delete. Fifth is traverse. Fifth is traverse. Sixth is search. Sixth is search. Seventh is exit. These are the menu options. Generally, when it is character-based programming, not GUI, not Windows-based programming, then we display this kind of menu. Finally, after the menu is displayed, we'll ask the user enter your option. So the user, in response to this, user enters the option, then we have to proceed with the option. So I'll say scanf, read the option %D. So read the option. Then based on the option, we have to switch option. So case 1, just will have a break, will not do anything. Case 2, break. Case 3, case 4, case 5, case 6, case 7. So these are the options we are going to have: 7, 6, 5, 4, 3. Just have displayed the structure of the menu, and it will display and do nothing. And if it is 7, it is going to be terminated. This is the program. First, I want to test this. So this is what is this? Yeah. So linked operations. Let's see. So it is displaying the menu. So menu is displayed, then menu options. If I select some option, it does nothing. Again, it displays the menu. Suppose again, if I give some option, again it displays the menu. 7, it terminates. So this is the structure. It is working fine because I'm not doing anything. I'm doing nothing when a particular menu option is selected. Now we have to perform the operations. So the different operations is first one is I'll declare the structure type def. I'll declare type def struct node. Here I'll say node int data struct node next. So this is a structure I have. I'll perform different operations like void. What are the operations? Void insert at beginning. Insert at beginning. So we'll send data to insert, and also we'll send pointer root node. So I'll take the root node. So I'll say node root or first node, just some name I have. So this is insert at the beginning. So I want to create the structure. So then insert at the end, at end. Then insert after given item, after given. So data to insert, and you should also have given item. So given I'm taking. So just I'm creating the structure. Then I'll say delete node. Delete node. Again, data I require to delete. Then I require the node, first node. Always it is required to start with it. Then I want to traverse. So again, we require the starting node. Traverse. Then we require what else? Search. node, first node of the linked list, then data to search or key to search. This we call it as key to search. So these are the operations. So how many operations? 1, 2, 3, 4, 5, 6, 7th is exit. So these are the operations. So I had to declare a pointer. So I'll declare a pointer first. So I'll say node start and I'll make it null initially. So that is the node we have to use, and we have to use the function, the corresponding function to call it. So if I have to insert, I have to call insert at beginning. I'll keep here insert at beginning. So carefully observe how I'm writing the program. So insert at beginning. So this requires starting pointer and also data to insert. So we have to read the data to insert. So that I'll call it as item. So I'll here write item int item. So I'll ask the user to enter that item to insert. I'll say printf enter data to insert item. So I'll read that scanf %d. So I'm passing the starting pointer and the item to insert. That is insert at beginning. Insert at end is also same. There is no difference. Only thing is the function name changes. Function name changes. So I'll use the enter data to insert item and insert at end. So I'll use insert at end. Same thing. Only thing is instead of inserting at beginning, I'm inserting at the end. So this is one more action I'm doing. Next is insert after given. So I'll do the same thing. Except what I have to do is I have to read one more item to insert. So enter data item to insert. That is the first one. And given item. So I have to go for a given item. So I'll say int given, because after given item we have to insert. So what is the function name I'm giving after given? So I'll take insert after given. So what we require item to be inserted and also given. So I'll take given. So read also given. So I'll say here, I'll read given item. So enter enter data after which new item. So this is we have to read item is inserted. So this is given. So I have to pass given also. This is to what we have to do to insert after a given item. Then for delete also we require item to delete. So I'll use this enter data item to delete. Enter data to delete item. So I'm reading it and I'll pause that item. So I'll say delete what I'm saying, delete node. Is it delete node? So instead of delete node, I'll say delete item. I think that is more suitable. So I'll use delete item. Here I'll say delete item. So what we require is we have to pass start and also pass item. So this is the next one. And next is traversal. So traversal just traverse. We have to pass start. So traversal is simple job. Then search. So for search, enter data to search. to search item. I'm reading that and I'll say search. Search, we have to say start and item to search. Or here I'll say key generally. Okay, let it be item. It does not matter. So this is the different things I'm doing. So if it is case one, it is insert at the beginning. I'm reading the item. I'm passing start and item. If it is insert at the end, I'm doing same thing. If it is insert after given item, in addition to the item to be inserted, I require the uh, uh, item which will be taken as a reference, after which the new item is inserted. And delete, we require item to delete. Fourth is delete option. Fifth is traversal, we have to visit all the nodes. And sixth is search for the given node. So given data item, I'm reading the data item. So I have built the operations, but the functions I have not yet defined. Now we have seen yesterday insert at the beginning because normally we are doing that, then traversal. So these two I'll do first. So insert at the beginning, what I have to do is first we'll see that. So already we have written the logic in the first program for insert at the beginning. So what I'll do is I'll take a linked list. Suppose there are two possibilities here. When start is null, means list is empty. This is first possibility. First possibility is list is empty. So you have to consider all possibilities. I told you list is empty. So when list is empty, what we have to do when a list has items, suppose start is having some pointer like 1200. Now I have already 1200, there is 50, and there is one more here 25. This is pointing to this, and there is one more, there is suppose 40, it is pointing to this. This is null. So this is assume that this is some address 1800, this is 1000. So there are two possibilities. Now we have to insert at the beginning. So to insert at the beginning, suppose I'll take a general thing here. So what I'll do is I'll take a new node. This I have to create new node. Then this should be inserted at the beginning. To insert at the beginning, what I have to do is the starting address, whatever is there, I have to copy into new node. So I'm creating a new node, P node, using malloc. Then P node next, what I'll do is I'll say start. P node next equals to start. That means 1200 is saved. This is the new node created. Then 1200 I'm copying here. So this points to this. Now this is no more starting node. So whatever address, suppose assume that this address is 2000. So store this address into start. So what you have to do is start equals to new node or P node, whatever it is, P node. So when I say start equals to P node, now 2000 is stored. Now the new node is inserted in the beginning. So start is going to point to this. So this is working. These two statements are required to insert at the insert a given node at the beginning. If there is already list existing. Now check whether the same thing is suitable for this. Now start is null. I'm creating a new node. This is P node, new node. Then start, I'm copying here. Yeah, this should be null. Last node should be null. So start is copied here. Now assume that this address is 1500. So start equals to P node. So 1500 is copied here. Now this will be pointing to this. So it works fine. The same statement works fine for both the cases. So I can use this particular set of statement to insert a new node at the beginning. So I'm going to do the same thing here. So here what I have to do is first to take a new node, pointer to new node, P node I'll take, and allot memory area for that. That is the first thing. If you want to insert the data item should be first memory should be allotted for new node. So malloc size of struct node or yeah. A struct node or node we can do. You can also use node. So I'm giving that. So the memory is allotted for that. Memory is allotted. So first new node we are creating. then move the data into that. So after I create the new node, data I'm moving here. This is the data. So that data I should move into the new node. So I'll say p node data, p node data equals to data. So this is the step. Next, I have to check p node. These two statements you write. P node next equals to start. P node next equals to start, and start equals to p node. This is logic for inserting the node at the beginning. So this is the logic for inserting node at the beginning. Here first I am saying not start. Start is passed as first. So make this as a first. This as a first, and this will say first. Now first equals to next. Next, so what here we have to give is next we'll say traverse. We'll first see traverse. So traversal means visiting each and every node. So take some current node. So say node equals to node current, p current equals to first. I'm attaching first node. Then as long as p current is not null, so what I'm doing here, assume that this is the list present. This is the list present. So what I'll do is I'll make p current point to this. Then I'll display, suppose if the data here is 100, I'll print this. 100 I'll print. Then I'll go to the next one. P current I'll move here. So I'll keep on move p current till it reaches null. So that is the logic. While p current not equals to null, equals to null. So I'll print the data, printf percentage d. I'll just display in the form of a linked list. So p current data. Then I'll say p current equals to p current next. So this is traversal logic. So traversal is common logic. Next. So this is how we have to proceed. So this is the program for just insert at the beginning. So I'll execute this. First equals to p node, not next. First equals to p node. So execute this. Semicolon. Execute this. What it is saying, delete item. Start spelling mistake here. Then what else? There is semicolon missing. So I think now all errors are corrected. Still there is something here, error ID return exit status. Malloc. Collaboration define reference to insert after given. So insert after given. So there is some spelling mistake here. Insert after given. Yeah. So I'll execute this. So now menu is displayed. So there is only one option we are doing, insert at the beginning. I'll insert. So insert 50. Now insert at the beginning. Insert 100. So 100 will be first node. Then I'll display. I'll try to traverse 5. So 5, what it is giving 5, it is not updating. So it is. I'll say 7. It is not getting updated. So we have to pass. It will be copy is passed. So when it is so what we have to do when we have to modify the address, we have to pass the pointer. Okay, I'll do this. Then I'll say asterisk first. I'll explain this. Then let me first do that. Then I'll explain what is happening there. What is the problem? So I'll take this. I'll execute this now. So 1, I'll insert 50. 1, I'll insert 100. Now I'll try to traverse. Traversal is 5. So I'm getting the traversal correctly. So what is the problem? I'll explain. Then I'll insert one more. So insert 75. So 75, 100, 50 should be there. So when I say 5, so 75, 100, 50. So this is okay, perfect now. So what was the problem here is earlier. So this is very important thing. This will help you to understand some concept. So what I was doing earlier is there was this is the first I have a pointer. I'll copy this. I'll explain what is happening there. This code. So this is the code insert at the beginning. So what I'll do, I'll take this code. Yeah, this is the code. So I'll do some correction here. I'll take it in the beginning because it is taking some space. This is why it is not working. That is important. So this is actually first. Initially it was changed. So this is first. Now I'll reduce this space here. So this is one code I have. Then what I'll do is I'll take this code where I was not giving this. So I'm calling this. So this is the statement used to call. Now this is in main, it is there. So now what is happening here is there is a start. There is a start. In main, there is a start. If it is not a global variable, that is very important. If it is global variable, it's okay. It's a local variable. See here, you can observe I'm not declaring it as a global variable. I'm taking a local variable. So I have start. Start is allocated with memory area and null is there. Now here what I'm doing is I'm passing. I want to insert 50. I want to insert 50. So I'm reading 50 here. So reading 50 and passing 50. So item is 50. Now this 50 is moved into this data. Data is 50 now. Now start, which is null, is moved into this. First is null. Okay, this is what happening. Now what I am doing, this is when I call this start is null, null is moved into first. Item 50 is moved into data. Now I'm creating a node. It is perfect. I'm creating a node. Then I'm moving data into this. This node is P node with some address. Assume that this address is 1000. I'm creating this node. Then I'm moving the data into this. I'm moving data. So 50 is moved. And first is null. This is null. This is okay. Then first equals to P node. So this is 1000. Now this is pointing to this. This is working fine. But what happened here? First equals to P node. Now start is still null. So I'm coming out of this and when I take first, this everything is lost. So because I'm not first is pointing to this, I'm not modifying start. So this is the problem when you don't declare the global variable, but it is recommended not to use global variables oftenly. We should not use global variables. Now what you have to do is instead of this logic, what you have to do is I'll take pointer to pointer. This one pointer to pointer. Pointer to pointer is one concept. Now I have to pass it by address. So because whatever changes made to first, I should reflect it. So 1 minute, I'll rewrite this. So this is the problem. So what I'll do is now I'm taking this. Assume that this is not now. Forget about this. Now start is null. Now I'm taking double asterisk here. Now I'm using ampersand here. Now, when I use this, start is null. The address of this is, assume that address of start is 4000 and it is null. Item is 50. Now, data here will be 50 as usual. Now, first is double asterisk. I am passing address of start, not value of start. Earlier, what I have passed, null I have passed into first. Now, what I am passing address of start into first. So when I take first, now first will have 4000. First will have 4000. That means it is pointing to this. Now I'm creating a node, new node. Then I'm moving data into this. Then here I have to use asterisk. Now when I say p node next is asterisk first. So p node next equals to asterisk first. Asterisk first is null. So this will be null. Now asterisk first here, because I'm passing this, asterisk first means go to the location 400, store p node. So what is the p node here? Now address of p node is 1000. Now 1000 is stored here. So now I'm modifying the start. So start is working. Now it is modified. You will get the result. Earlier case, we are just modifying first, not start. So you are getting the problem. So this is one common problem you will be facing if you don't take proper care. So this is how you have to do it. If you want changes to be reflected on the main program, then you have to pass by address. So that's what I'm doing here. So after I pass by address, now I'm getting the result correctly. So I'm taking here when it is passed by address, start is already a pointer. So if I pass address of a pointer, it is pointer to pointer. So that's why it should be double asterisk. Then here each time I have to take the value of first and modify the value of first. So this is insert at the beginning. Now insert at the end also I'll do similar thing. So insert at first actually we can pass similar way, but it is not going to be modified. It is going to be modified. It is not going to be modified each time. Only first time it is going to be modified. Anyhow, it is always better pass by address. So I'll take this double asterisk here. So what I'll do here is I'll also pass address of start, not start itself. So here again, I'll pass address of start. Wherever you want modification to be implemented, you pass address. Otherwise, don't pass address. Now, if it is insert at the end, again, there are two cases. Insert at the end, there are two cases. One is start is null. This is one case. Second case is there is already some list. There are two special cases here, two possibilities. When there are nodes, suppose start is having some address, suppose 3000 you assume. So 3000 is this address and this is pointing to this. Assume that this is 10 pointing to this. Assume that this is 20. This is pointing to this. This is not. There are two possibilities. So what I'll do is I'll create a new node. I'll take first general thing. I'll create a new node. So this is P node. This address, assume that this is 1800 and the data here 30 and this is 40. Now it should be as per our requirement, what we are saying, insert at the end. That means this node should be inserted here. But I have pointer to the first node. So what I have to do is I take P current and reach the last node. P current reach the last node. How do we reach the last node? So take P current equals to start. Then what I'll do is while P current next not equals to null, I'll keep on move P current. So this is the logic I'm going to use. So I have to go to the last node, but I don't have pointer to the last node. So what I have to do is take P current equals to start or first, whatever it is. Then while P current next not equals to null. So as long as there is next node present, we'll proceed. So I'll say P current equals to P current next. Now initially P current is pointing to this, P current next is not null, it will go here, P current next is not null, it will go here, then P current next is null. Then after coming out of the loop, so when loop is terminated, P current is pointing to the last node. Then what you have to do is P current next equals to P node. So this will be P current equals to P node. Then this should be made null because it is going to be inserted as last node. So this is if it is already the list is existing. Now if I take the same case, now P first is having the null. Now P current will be assigned null here. P current is assigned null. Then while P current next, when we try to do this, it is an error because P current itself is null. So we are trying to use the pointer which is not having some valid address. So it is going to be error. So this logic is shootable only when the list is already present. If the list is not there, list is empty. So how we know list is empty? Check whether first is null. If first is null, simply say P first equals to P node. That's all. This is when it is this is the special case. So when you have to insert at the end, consider one special case. If the list is empty, just make the pointer starting pointer point to the new node. Otherwise, go to the last node and attach. So this is the logic we are going to use for insert at end. So to insert at end, what we do is the to same thing I'll take here. These statements here are same. This statement I'll take as it is. First two statements, I'll create a node, then I'll allot memory area, then store address. Now the new node always is going to be the last node. So when it is last node, what you do is make its address null. Make its address the next null because it is going to be the last node. Now check one special case. If asterisk first equals to null, so asterisk first is equals to null, it is a special case. This is a special case. Special case when list is that special case is list is empty. So when list is empty, you have to consider this. So if list is empty, what I'll do is asterisk first equals to P node. Then I'll stop. I'll not do anything. So this is when list is empty. Otherwise, if you are coming here, then if you are coming here means list is not empty. List is not empty. When list is not empty, then we have to take a node. I'll declare, okay, here I'll declare a node P current. So I'll make P current point to start. P current equals to first. And while I told you the logic, general logic, so P current next not equals to null. As long as we till we reach the last node, we have to keep on move. So we'll say P current equals to P current next. This is how we do it. After we reach the last node, says P current next. P current next equals to P node. That's all we have to do. P current next equals to P node. So this is the logic. This is the logic for insert at the end. Now we'll execute this. So first I'll insert at the beginning. So 10. Insert item 10, enter data to insert. Somewhere I think some correction I have made. I did not do it. So insert at beginning double asterisk. Here am I passing address or not? I had to pass address here, so that is the mistake. I think, yeah, now it should work fine. So I'll take 1. First, I'll insert at the beginning. So 10 I have inserted. So if I try to display, which is traverse, we'll get 10. Now, before 10, I want to insert 50. So again, insert at the beginning. So 50 I'm inserting. So now I'll display 5. So 50, 10. Now I'll insert some node 100 at the end. So I'll say 2, 100 at the end. Now if I say traverse, it should be 50, 10, 100. So traverse 50, 10, 100. Then again I'll insert a node in the beginning. So 25 I'll insert in the beginning. So I'll check again 25, 50, 100. Now I'll insert 40 at the end. So 2, 40. Now if I say 5, so we are getting fine. So it is working fine when the list is already existing. Even if you insert a node at the end. Now what I'll do is I'll insert the node at the end when the list is not there. When list is empty, that means in the beginning itself I had to do. Now insert, enter your option 2, list is empty. I'm inserting new node. Suppose I'll insert 50, check whether it is working fine or not. So 5, so we are getting 50. Now again I want to insert at the end. So 10, I should get 50, 10. So 50, 10, so it is working fine. Insert at the end is working fine. So this is the insert at the end. So I'm writing the logic by considering one special case. This special case is when list is empty. When list is empty. So next, insert after a given item. So insert after a given item. So that is one more option, insert after a given item. There are special cases when list is empty, start null. Second special case is when list is there, list is there. So 10, 25, suppose 20, list is there. Then list is there. Then this is start. Start is pointing to this. Sorry. Start is pointing to this. Now I want to insert 40 after 25. So 40 I have to insert after 25. So I have to reach here. Then in between I have to insert. In between these two I have to insert. So what I have to do is whatever address present here. Suppose this is assume that this is 1000. 1000 will be present here. 1000 is present here. Then this is 2000. 2000 is present here. Then this is 2400. 2400 is present here. And this is null. And now this is the new node. I have to insert 40. After assume that this address is 1800. Now I have to insert after 25. So when I reach after the given node, when I reach this here, one special case is start is empty. Second special case is when item after which we have to insert, after which we have to insert. So I'll take this special case here. Yeah, item after which we have to insert. So item after which we have to insert is not there. So that I'll take a special case, not there. So that means suppose here instead of 25, I'm saying insert after 50. Now 50 present, not present, not present. I'm getting the list exhausted. So when it is not present, so I have to insert that new node as last node. So that is another special case. So item after which we have to insert is not there, then we have to insert at the end. So this is one special case. Second case. The third case is, see, this is little complex. Third case is, now I have to insert items. So 10, 25. There are again, the item to be inserted is found. So this is there. This is start. Start is present here. Start is present. So I'm pointing to this. Now I have to insert 40. I have to insert some node after a given node. Given node is this is 20. Assume that this 25 after 25. Then if it is after 25, what I have to do is assume that this is 1000. Like earlier I took, this is 2000. This is 2400. New node I'm creating, it is 1800. So what I have to do is remove this link. So whatever address you are getting here, copy this address here. When I copy this address here, then when I copy 2400 here, then there we are creating a new link between this. Then copy this 1800 here. Then I'm adding this here. So it is inserted in between. So the third case is when the item after which we have to insert is found. But where it is found, this is also one special case. If it is found in the middle, So this is one special case, 3A, if it is found in the middle. Suppose if it is end, So if it is end and the middle will work fine. Here what you have to do is, this is the given node, P given. This is the new node, P node. So what I have to do here is, the logic what I have to do is, P node, new node, next equals to P given. Next. So that means P given next is 2400. It is copied here. Then P given next equals to P node. So it is copied. Suppose if it is the last node, this is the given node. Then this is the node. Then P node next. This is null. It is copied here. P given next equals to P node. So it is working both the cases. Is found in the middle, and B option is at the end. Both the cases it is working fine. But there is one more special case here, 3C. The 3C special case here is, so this is how you have to consider all options. The third, another special case after if you have to insert is the given node is the first node. So given node is the first node. Even if it is given node is the first node, so this is P given. So I think there will not be any problem. Given node is the first node. So P given. So P node next. So it is okay. It is working all these three special cases. Whether the given node is in the beginning or in the middle or in the end, the same set of statements are working fine. So you can go through it. So this is the logic I'm going to write. So insert after given node. So again, this is double asterisk. What I'll do here is start. I'll write start here. I'll write ampersand start. So insert after given. So what I'll do is I'll take a new node. First thing, because I have to insert the same statement, I'll take care. I'll take these statements. Current is not required. Is current required? Yeah, I will take that. Current, I'll take it as given. So new node creation is same when I have to insert in all the three cases. So P current, what I'll do is I'll say given. P given instead of current. So this is I'll consider one special case. The first special case here is when list is empty. When list is empty, then simply you need not search for anything. So if asterisk first, this is special case when list is empty equals to null, then I need not search for anything because list is empty. This is special case, list is empty. List empty. When list is empty, I have to simply copy the address and stop. So asterisk first equals to p node and return. P node and return, and here we have to make what I'll do is p node next. P node, if it is null, what I'll do is I'll say p node next equals to null. So this is when list is empty. Second special case is when list is not found. How do we know when list is not found? When it is not matching. So I'll take given given node. What I have to do? Given node, after given node. Suppose if given node is empty, then I'll write the logic here. So p given, what I have to do is p given, I have to start with first. So I'll start it with first. Then I'll say p given. First thing is not equals to null. This is first step. Not equals to null, and p given data not equals to p given data not equals to given. So once it is given, we have to, we are searching till match is found or we reach the end of the list. So in that case, I'll be just keep on moving. P given equals to p given p given next. So I am keep on moving the node till we reach end of the list or matching node is found. Now here one special case what we have to consider is if the node is not found. So node is not found. So when node is not found, we have to insert it at the so we have to follow another node. So p previous. So we'll take one more p previous, because we have to follow, otherwise we will not get that node. So p previous, also first. Now what I'll do is p previous. Now if I say if p given is equals to null, the special case is node is not found. The node required given node not found. This is the case. Required given node is not found. When required given node is not found, we are taking the previous node. So it should be attached as the last node. So p previous next, p previous next equals to p node, then p node equals to p previous next. So it will be inserted as last node. So that is what happening here. When p given is not null, equals to null, means required given node not found. Suppose if it is found, so given node found. So when given node found, what we have to do is just p give. We have to use this logic, whatever I have written here. What I have written, p node next equals to p given next. P node, it has to be inserted after the given node. P node next equals to p given next. Then so p node new node p given next equals to p node. So this is the logic. So there are some special cases. First is when list is empty. Second one is when given node is not found. Third one is when given node is found. These are the actions we have to do. All options I am taking care to insert after a given node. So this is we'll check whether it is working fine or not. I'll execute it. So first I'll insert when I'll try to insert after a given item. So 3 list is empty. So insert enter data to insert. I want to insert 50. Enter data after which this is the first node, but it will be inserted. So I should get 50 there. So 50 I'm getting. Now I'll again insert. Now what I'll do is I'll insert after a given node. So after a given node, I'll try to insert after 50. Or otherwise I'll insert, I'll try to insert after 50. So what I'll see 3. So insert to item to insert, I'll say 60. 50 after 50 I have to insert. So check whether it is 50, 60 is coming or not. So 5. So 50, 60 is coming. Now again I'll insert after 50. So 3. Insert item to insert is 55. So after 50 I want to insert. So I'll check whether it is inserted successfully or not. Yeah, it is getting inserted successfully. Again, I'll insert. I want to insert 75. I want to insert data item to insert. I want to insert after 45, which is not there. When I have to insert after the item which is not there, it should be inserted at the end. So 75 is not, it is not inserted. So what is the problem? So if 45 is not found, I'll check whether the logic what we are writing is correct or not. So if it is not found, so what I'll doing, p previous equals to asterisk first, p given not equals to null, p given data not equals to given. So when p previous equals to p given equals to p given next. So when p given is null, so what I am doing, p node next. Oh, there is here I'm doing mistake. So here I should write next equals to p previous next. Yeah, that is the mistake. Now I think it will work fine. Yeah, I'll repeat this. So some mistake here. I have to close this. Yeah, this I think I have to close because it is still under execution. I'll close this. Now it should be executed. So 1, I'll insert 50. Okay. Then insert at the end 2, 70. I'll insert. Now I'll insert after 50. So item to be inserted is 55. After 50 I'll insert. So 50, 55, 70. So if I say 5, 50, 55, 70. Now I'll try to insert after a given item which is not there. Earlier it was giving error. So insert item is 60 or 75 I'll give. And item after which I have to insert is suppose 60. It is not there. So when it is not there, it should be inserted at the end. Now it is working fine. So the logic, there was a small mistake in the logic. So it is working fine when the node is not found. Now, if the item to be inserted is the last node, that will check. So 3, enter your option 3. So I want to insert 80 after 75. The one special case I'm taking, whether it is working fine or not, I have to check 5. So it is working fine. So all cases of insert after given item working fine. So this is how we build the logic for insert after a given item. This is slightly complex. See, for everything you draw a diagram, and if you have any confusion for anything, draw a diagram, then things will be clear. So this is insert after given item. So next we'll see delete an item. Delete an item. So to delete an item, we require node to be deleted or item to be deleted, and I have to pass the starting address of the item. And what I'll do is I'll take here double asterisk, sorry, traverse delete node. So I had to delete a given node. So again, I'll take some special cases here. So whenever you want to perform some operation, you check all possibilities. So one special case is one special case is when list is empty, start is null is one special case. Second special case is the list is there. So list is there. Suppose 10, 20, 30 list is there with some starting point and start is there. Now 1000, so 1000 is pointing to this, this is pointing to this, this is pointing to this. Now I have to delete item which is not there. So this is one more case. So I am keep on searching. If I don't find, I have to display the error message saying that it is not found. That is when list is empty, this is list is empty is one case. The second case is required node not found. List is not empty, required node not found. Required node not found. Now both these cases we can do it with one statement. So what I'll do is I'll say p current equals to start or first, whatever it is, and if I p current becomes null, so p current check whether it is matching with 10, not matching, matching with 20, not matching, not matching with 30, not matching, p current becomes null. So when I say p current equals to null and while p current not equals to null, if I do it, if p current equals to p current next, then if p current becomes null, then p current becomes null, then the node is not found. So these two I can consider with the same logic, like assign the starting address to p current and keep on traverse till you reach the null, and when it is not matching, keep on traverse till you reach the end. Once you reach the end and p current is null, then the required node is not found, you can stop. That can be taken care with this. Suppose if it is found, then p current will not be null. Once it is found p current is not null, again this is node is found. Node is found. When node is found, what is the node to be deleted? If it is the last node, then it is a problem. So if it is the last node, or assume that it is the middle node. So first special case when it is found is middle node. When it is middle node or middle node, say when it is middle node, this is the node to be deleted. Now this node should be bypassed and this should be modified and point to this. So always whether you have to maintain the previous node to the current node. Previous node to the current node you have to maintain, because once you need get the reach the required node, then the previous node pointer you have to adjust. This is how you have to do. So you have to keep track of the previous node. So when you keep track of the previous node, then this is the previous node. This is the previous node. Then this is the current node. Then I can bypass. Suppose if the node to be deleted is the last node. Last node. So this is p current. Then this is p previous. Then this is bypassed and here null is stored. So these two cases will be taken care with the same set of statements. This is second two special cases when node is found. Third special case which should be taken care separately is when node to be deleted is the first node. When node to be deleted is the first node. So when it is the first node, then what you have to do is you have to modify the first node itself. So suppose if I have to delete this current node, this is the node to be deleted matched, then I have to modify this first to point to this. So this is the logic. So I'll take first the statements here, delete item. So when delete item, what I'll do is I'll take some current node. I required current node, p current, then p previous, both are required. What I'll do is I'll set them to p first So P current equals to P previous equals to first. So I'm pointing it to first. Now what I'll do is I'll say while P current not equals to null, means I'm not finding the node. I have to repeat the process till I reach the last node or till I find the node. P current data not equals to data. So till I reach the last node or match is found, I have to do it. Then what I have to do here is P current P previous equals to, I have to always follow P previous should follow P current. So P current, then P current equals to P current next. P current next. So this is the logic to reach. Suppose if one special case here is if P current is null, P current is null, then the required node is not found. So I'll say simply printf the node with data %d is not found. That is the message. So there is nothing to delete. The required node is not found. So I'll say here, what is the data? Data. So it is not found. We can stop. We can stop that. If it is found, then what we have to do is if it will not be null. Now, if it is not null, one special case is if check whether it is first node. So if it is first node, how we know whether it is first node? When it is first node, both P current and P previous will be pointing to the same node. So P current equals to P previous, means both are pointing to the same, then it is the first node. So when it is the first node, what you have to do is I'll say asterisk first equals to P current next. So the first itself is moved. Now I have to delete P current. So this is the when it is first node to delete. If it is not first node, then what I have to do is I have to bypass the current node P previous next. P previous next equals to P current next. So this is I think this is the logic we require. The logic is not that much difficult. Now P current is freed. P current is freed. So what I have to do is I have to say free P current. And you say and display message printf the node with data %d is deleted successfully. So I'm also releasing the memory. That is one important thing. Also releasing the memory. So I'll explain this delete again. So if it is if it is empty, there is no problem. If it is empty, no problem. So what I'll do is I'll take, I'll explain this, what I am doing there. So assume that first start is null. So what I'm doing, P previous is null and P current is also null. So P current is null and P previous is null. So P current not null. So it is already null. So when it is null, so what I'm saying, the node with data %d is not found. So it will not do anything. This will be taken care. Now suppose if this is the list 20, 30. Now when this is P, this is start is assume that this is 1000. So this is 1000, this is 2000, this is 3000, and this is null. Now I had to delete from this. I had to delete 50 from this. Now what we are doing, P current I'm making it to the first and P previous also we are making it to first. So that's what we are doing here. So initially what we are doing in the deletion, P current and previous, we are making it faster. So we are storing 1000. So this is pointing to this. This is pointing to this. Now I'm checking P current not null. True. P current data is not matching. So P current data is not matching. So what I'll do is I'll copy current value into next previous. So this is copied here. It is, of course, it is same in this case. Then I'm making current point to this. Now this is 2000. Now again, it is not matching. When it is not matching, this 2000 I'm storing because previous should follow the current. Now current will be 3000. Now again, it is not matching. Now 3000 we are storing here and this is null. When it is null, that means the required node is not found. So that is one more case, required node is not found, our list is empty, it is working fine. Now suppose if I take again some data 10, 20, 30. So this is pointing to this, this is pointing to this is null. And assume again this is 1000, this is 2000, this is 3000. Now P current, what we are doing, we are making 1000. P previous also we are making 1000. So both are pointing to this. Now this is first is having 1000. Now what I want to delete now, I want to delete 10. So when I delete 10, what happens? P current not equals to null is true, but P current data is matching. So it is matching. Then the loop is terminated. It will come out of the loop. Now current is not null. It is not null, but current and previous are same. Current is 1000, previous is 1000. That means it indicates that I have to delete the first node. To delete the first node, what I have to do is P current is pointing to this. What I am doing, I am modifying the first. So first I'm modifying to 2000. So this is made modified to 2000. Now this is ready for deletion. So I can delete. So that's what happening. Now suppose if it is not first node, I have to delete 20. Then when I have to delete 20, P current is pointing to this 2000 and P previous is pointing to 1000. Now I have to bypass current. So what I am doing previous next. Here what I am storing P current next. P current next is 3000. 3000 is stored. Now this is bypassed. So now I can delete this. So that's what happening. So this is the deletion. It is done without any problem. So next we'll check whether it is working fine or not, because our manual verification saying that it is correct, but we'll check with some data. Then search, I'll do it. Search, just I'll take this logic. I'll take this logic for search. This is the logic we require. For search is simple logic. Required data is found or not, we have to check it. So I'll take here only current. So node current, P current I require. I want just first. Now I don't require address, I just require a copy. So I'll take first here. Traverse also, yeah, it is not double asterisk, single asterisk. Yeah, it is correct. So I'm storing P current equals to first. First, then P current not equals to null, P current data equals to key. So till match is found, we have to do it, and this is not required. Just we have to move it. So once P current is null, if P current is null, the required node is not found. P current is null. I'll say it is not found. Printf percentage key percentage D is not found. Otherwise, we'll say it is found. Just we are displaying whether it is found or not. Else, so search is very simple logic. Else, it is found. P current is found. That's all. Now we'll execute. Now full program is there. I have written everything. So somewhere I'll execute. So it is okay. Now I'll insert at the beginning, I'll insert 10, insert at the end, I'll insert 20, insert at the end, I'll insert 30. So 10, 20, 30 should be the data. I'll insert 25 after 20. So I'll say 3, insert 25 after 20. Now I'll say 5. So 10, 20, 25, 30, everything is fine. Next, now I want to delete the item which is not there. So I want to delete the item which is not there. So 4, I'll say I want to delete 50. So it says node with data 50 is not found, and the list should remain same. It is remaining same. Now I'll delete the item which is found and middle. So I want to delete 25, which is at the middle. So I'll say 25. Now node with data 25 is deleted successfully. So I'll check it. So it is giving fine. Now I will delete the first node. That is one special case. So 4, I'll say 10. Now check node with 10 is deleted successfully. The output should be 20 and 30. So I'll say 5. So 20 and 30, it is working fine. Now I'll delete the last node. That is one more special case. So 30 I'll delete. So 30 is deleted successfully. Now only 20 should be there. I'll even delete that 4. Now I'll delete 20. Node with data 20 is deleted successfully. Now I'll try to display. Nothing is displayed because the list is empty. Now I'll again insert. So I'll say 25. I'll say 5. 25 is there. Again insert at the end 50. So 5. Now I'll one more I'll insert in the middle. After 25 I'll insert. So I'll say 3. I have to insert 40 after 25. Check whether it is, yeah, it is fine. Now I'll search for a given item. I'll search for 60. So it says key 60 is not found because it is not there. Again I'll search for an item 40. So I'll say key 40 is found. So all the